Hello, future chemists. It's Lara again. I'm going to tell you a little bit more about the bridging course. This time we're going to be talking about atoms and elements. So we'll talk a bit about the periodic table, about atomic structure, atomic number, mass number, atomic mass, and some isotopes. Again, for some of you, this information is going to be super familiar, so you can skip through it quickly. For those of you who've never done this before, maybe listen to this once, maybe listen to this twice. So in terms of elements, they're pure substances and they cannot be separated by chemical methods into simpler substances. So if you remember back to lecture 1 when I was talking about matter, I said you can have a copper coin and you can break it down into copper particles, but that's as small as it can go. So when we have 2 or more elements that are chemically combined in a fixed proportion, they will form a compound. And we keep talking about water because it's around everywhere. So water is a compound of hydrogen and oxygen. And if you go through the process of electrolysis, you can actually separate hydrogen out, the hydrogen out and the oxygen out, which would then make them elements. At the moment, there's a total of 116 different elements that have been identified. Each of these has a unique name and a unique symbol. 92 of these are actually naturally occurring, and some of them we've been able to make. It's very important to learn the names and the symbols for these. Those of you who've done chemistry before will probably know the first 20, and I'm sure you've all heard of the periodic table song, which we'll put a link up for you on Leo's site. So in terms of the periodic table, this is something that gives the names and symbols of the elements. The elements are arranged here according to their properties. Groups, which are the ones that go down in vertical columns, contain elements with similar properties. And periods are horizontal rows of elements. So what that means is a group is down and a period is across. So as you go down groups, you'll find that those elements have similar properties. In terms of the way the periodic table is set up, well, we've got things here in group 1A called our alkali metals, and in group 2 we have alkaline earth metals. Then from 3B all the way over here we have transition elements. Over here, these yellowy orange ones, they are our non-metals. Here we have metalloids. And these last ones on the end here, these are our noble gases. I like to say that they're like kings and queens, and everybody else wants to be like a king and queen. The reason that they're called noble is because they are stable. They are very, very stable elements. And we'll talk a bit more about them when we get into the course. So this is just a summary of that for you. Group 1 is the alkali metals, Group 2, the alkaline earth metals, Group 7, halogens, Group 8, noble gases, and Groups 3B to 12B are the transition metals. There is a separation in our table based on metal, non-metal, and metalloids. Metals are located on the left-hand side, non-metals are located on the right-hand side, and the metalloids are that zigzaggy line in between the metals and the non-metals. And the reason we separate them out into these 3 different classifications is because they are actually very different in terms of their properties. So again, here we've got our metals, here we have our non-metals, and here we have our metalloids. Now you'll notice there is one non-metal up the top over here. This is poor lonely old hydrogen. Hydrogen is not a metal, but the periodic table has been set up based on the number of protons and neutrons within that particle, and so this will stand alone over on this side. So in terms of these 3 different types of groups, the metals, all metals are shiny and they're all ductile. Almost all of them are good conductors of heat and electricity. Non-metals are mostly dull and brittle and they don't conduct anything very well, but they're really good insulators. Metalloids, they're better conductors than the non-metals, but they're not as good as metals. And they can be used as semiconductors, and they can be used as insulators. So this is a group that sort of sits in between. It's not a metal and it's not a non-metal. It's sort of half-half. So this is just a really good table to help you compare the difference between a metal, a non-metal, and a metalloid. There are exceptions to this rule. I will point that out now. But one of the things that we didn't talk about was the density, and there's a pattern in the density. There's also a pattern in the melting point between the different characteristics of the different groups. So non-metals will have a very different sort of set of melting points to metals, for example. We've got sulfur here. Sulfur's melting point is at 111 degrees Celsius, but if we look at a metal, the melting point is 962 degrees Celsius. So it has to be really, really, really warm for this to turn from a solid into a liquid. The same is not true here. So use that as a table as a reference point. So if we've got all these different elements, 119 of them in the periodic table, what is it that makes them different? How do they differ from one another? Well, it all comes down to the atom. Elements consist of extremely small invisible particles called atoms. An atom is the smallest particle of an element that can retain the characteristics of that element. A particular element consists of identical atoms. So if we look at our copper coin scenario, a copper coin, we break it down, it's into small copper particles. Those copper particles are actually copper atoms, and each copper atom is the same as the next copper atom. But atoms of different elements have very different properties. Now what an atom consists of essentially is a nucleus, and inside this nucleus there's these subatomic particles called protons and neutrons. Protons have a positive charge, neutrons have no charge, so they're neutral. And then around this nucleus, there's this sort of haze of electrons. And these are tiny, 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 tiny particles. And they have a negative charge to them. Now, what we know is that although it's really small, because we're talking about AMU as our mass range here, so it's tiny, our protons have a mass of about 1 AMU. Our neutrons also have a mass of about 1 AMU. But if you look at the electrons, they're so much smaller. So this hardly contributes to the weight of the atom at all. And again, we can see here we have a positive charge. The neutrons have no charge, and an electron has a negative charge. This tells you whereabouts in the atom they're located. It's either going to be the nucleus or outside of the nucleus. Now, most of the atom is actually empty space. The protons and the neutrons, they carry most of the weight, they carry most of the mass, and that's in the nucleus. So 99% of the mass of the atom is actually in the nucleus. The space around is all dealt with the negatively charged electrons. And that's around here. And sometimes it's called an electron cloud. When we start talking about the particles in a little bit more detail, when we start to enter the true chemistry course, we'll learn that these electrons are actually placed in a sort of, it is structured the way they exist. But for now we're saying that it's a cloud around the nucleus. Now, one thing that we should note is that electrically an atom is neutral. So we have positively charged protons and negatively charged electrons, but they are in the same amount. So the overall charge will be neutral. We'll learn about ions in a little bit, and that is where there is difference in charges. But in terms of the atomic structure for an atom, their overall charge is neutral. In terms of the way we distinguish these atoms, we give them something called an atomic number. And what the atomic number is, it stands for the number of protons in an atom. And this is specific for each element. And it is the same for all atoms of a given element. So if we look at our little friend Hydrogen. Hydrogen has 1 proton and it has 1 electron. Helium has 2 protons and 2 electrons. Lithium has 3 protons and 3 electrons. Carbon has 6 protons and 6 electrons. If it only had 5 protons, it wouldn't be carbon. So each element is very specific in terms of its number of protons. We also know the mass number because we remember that I said that protons is equal to 1 AMU and a neutron is equal to 1 AMU, around about. So you can calculate the mass number. So if we look at oxygen, we know it has 8 protons, therefore it will have 8 neutrons. So it has a mass number of 16. Sometimes you'll find this in the periodic table and sometimes you won't. It depends on the version of your periodic table. In terms of the mass of the atom, the atomic mass or the weight, well, what we know is we know that the electrons, they hardly count for anything at all. And we know the proton's mass and we know the neutron's mass. So we can essentially work out the atomic mass, just as the mass of the neutrons plus the mass of the protons. And that will give you the mass of the atom. But the mass of the atom is not to be confused with other things, and it can be varied because sometimes we have these things called isotopes. Now what this means is that all atoms in an element have the same number of protons because carbon always has 6 protons. If it doesn't have 6 protons, it's not carbon. But the number of neutrons can actually change. And when they're changed, this is called isotopes. So if we have a look over here, we've got carbon. It's carbon because it has 6 protons, but this one here has 6 neutrons. This one here actually has 7 neutrons. So there's a difference in terms of their mass because it's a different number of neutrons. But all isotopes of an element will have the same chemical properties because they will all have the same number of protons and the same number of electrons. And that is what is important in determining the atomic characteristics. So hopefully that gives you a little bit of an understanding in terms of atoms and the little components within atoms. And what we'll do is we'll build on this in the next little lecture where we start talking about electrons and chemical bonding. So see you soon.